So our proposed solution is rerouting packets going to congested link. This way, avoiding delays and increasing the quality of video that's being transferred. On the left, we have congested link and ordinary shortest path algorithms that would route packets through the shortest path, thus creating congestion. And on the right is our solution. Black box is basically what was our objective. We reached this by using P4, and the final goal was rerouting the packets through a different switch, thus decreasing the delay, congestion, and increasing quality of video. So the solution approach, there are several ways to achieve it. One of them is source routing, another one is packet cloning. Before P4 switches themselves could be considered as stateless from my understanding. P4 switches do not have any information about general congestion in the topology unless it's included in the packet. The way of including it in the packet is through inbound telemetry. So what source routing is, when the source, someone who is sending the packets, would include in the packet the exact route through which packets needs to go. But for that, source would need to know the entire path and should have all the information about the topology and congestion. And to achieve that, we would need to have feedback system that's basically loop, and once the destination receives information about congestion, it needs to send all that information to source so that source plans the path. Another solution is packet cloning. What packet cloning does is it just whenever congestion is identified in one of the links, it just clones out the packet and sends it through another link. But this approach also has some limitations. The question is where to clone, because at that state, switch itself does not really know which port would finally deliver the packet to destination. So it can just randomly send it to different ports. And this might in terms create even more congestion. So ideal solution would have been combining all these methods and creating some control system that would know the entire topology, congestions, and would be able to solve the issue at ingress level and not waiting until egress finds out congestion. But running ahead, once that black box is achieved, what we will have is the following topology. When video from edge or high volume videos could be sent from H1 to H2 through uncongested link. And when we send another video from H3 to H4, we could do it using an alternative route that is free of congestion. Implementation of this logic could be seen in our example. On the leftmost, we can see host 1 that would send videos to host 2, and here host 11 would send video to host 22, and that would take an alternative route through switches 1, 3 to 2, and every packet would include the switch trace depths at every switchboard. And on this end, we can see congestion information and switch trace of the link from S1 to S2. So let's see. We have started streaming the video from H1 to H2. We can observe that there is no considerable delay. There is no queue. Now we would start streaming video from H11 to H22 and see if it would influence other link. You can observe some lagging, but that's not because of network, but because of my laptop and its limitations. As you can see on both MRIs, Q depths that defines the congestion is equal almost to 0 in all cases, meaning that we have achieved what we planned. Thank you for your attention.